Now that we've spent some time factoring quadratics and factoring polynomials, we're going to use those skills to start solving quadratics. So no longer are we factoring, we are going to be solving quadratics. Now we're going to solve quadratics two ways today. One of them is by graphing. Now this is going to sound familiar from Algebra 1. It is also the way that we are going to check all of our work today. So to solve by graphing, all we have to remember is the acronym ROCKS. Now, hopefully you remember this, because in Algebra 1, we introduced the acronym ROCKS to stand for the roots, the zeros, the x-intercepts, and the solutions. Now, that last one is super important because if we are solving quadratics, then all we have to find is the solutions. But the solutions are the same exact thing as the roots, the zeros, and the x-intercepts, which means we really just need to find the x-intercepts of that graph, which is the places where the graph crosses this horizontal axis, which is why we have a line drawn through the word rocks. We want to find where it crosses the x-axis, or the flat axis. So what we can do to find the solutions to any quadratic is once it's either set equal to 0 or equal to f of x, we can go ahead and find the solutions by graphing. So I'm going to place a video here on this slide so that you can see how this works. And I want you to be able to do the same thing. So here we go. We are going to solve by graphing. We type in f of x equal to x squared minus 6x plus 8 into Desmos or your graphing calculator. And then all you do is simply look to see where the graph crosses the x-axis. And that is the solutions to this equation. That is the solutions to this quadratic. So let me move this down for a second. What we saw on the graph was when we graphed that function, it looked like this. And it crossed the x-axis at the coordinate points 2, 0 and 4, 0, which means I know immediately that my solutions are x equal to 2 and x equal to 4. Now we're going to utilize this skill pretty much the whole class period today to check our work so that we can find our two solutions. Now there is a possibility that your quadratic can have only one place where it crosses the x-axis. It would be called a repeated root. Or it can not cross it at all, which would mean we'd have no real solution. So we're normally looking for 2. There's a possibility you only have 1 or no solutions. But the way we're really going to be finding all of our solutions today and how we're going to practice is by factoring. Now, obviously, I've done this first one for you so you can just look at a nice clean example. There are 3 steps to solving by factoring. Step number 1, you're going to need to set the equation equal to 0. Now, I want to move all of my terms towards the x squared term. Notice here that I was given 3x squared equal to, and then a whole bunch of stuff. I don't want it to have numbers on both sides. I want one of the sides to say equal 0. So all I did was pick up this negative 15x and plop it onto the correct side. But when you cross the center line, you cross the equal sign, you just have to change the sign. So negative 15x became positive 15x. And the 72, when I drop it over there, it also changes sign from positive to negative. But once I have it set equal to 0, I revert back to all of my factoring steps. Factoring is what we did a couple days ago. So you can look back at those notes if you need to. We always start with finding the GCF first. This one has a GCF of 3, so I do the GCF step. If it doesn't have a GCF, then you can skip this step. We factor out the GCF, and then we start doing the X puzzle, which I have written here. That's step 2. Now, you may possibly have a difference of 2 squares, but if you don't look and notice that pattern, you're always going to go to step number 2 and do your X puzzle. If you need help on how to do an X puzzle, there's a whole other explanation video for this. But I'm going to factor A times C in the top, B in the bottom, A underneath, and find the numbers that would multiply to negative 24 and add to 5. I notice that 3 times 8 is 24, and if I subtract those, I get negative 5, which is the correct number but the wrong sign. So instead of positive 3, negative 8, negative 3, positive 8 is what I use. I divide if possible, which is possible on both of these, and then I'm going to take both of these numbers and drag them down to my factors. That's where we stopped last class. But because of something called the zero product property, I can move on to step 3 and set each factor equal to 0 and solve for x. Because of the zero product property, which says that anything multiplied by 0 is 0, we know either the first part, the GCF, is 0, the first parentheses is 0, or the second parentheses is 0. So I take in green each of those little pieces, the GCF, the first parentheses, and the second parentheses, and I set them equal to 0. But if you notice, that first thing, my GCF for this problem, is going to give me the math sentence 3 equal to 0. And no, 3 does not equal 0. So we just stop right there. That's just not making any sort of sense. But if we go to the second one, x minus 3 equal to 0, well, that's an equation I can solve. I'm going to add 3 on both sides so that I get x equal to 3. And voila, there's one of my solutions. On the second one, I would do x plus 8 equal to 0, subtract 8 from both sides, and solve for x equal to negative 8. Now, before I move on from any one of these problems when I find solutions, I want to verify graphically, and I'm going to leave this for you to do. Okay, I want you to take this equation, the one that's solved equal to 0, so the red step, and I want you to throw that into Desmos or some other sort of graphing software so that you can also verify that this graph does cross at negative 8 and 3. Now we're going to go inside here, we're going to see a few examples again, and that's pretty much the gist of today. We're going to be solving these quadratics by factoring and then verifying graphically each time so you can check your work. All right, as you may notice here, I also did this one. It is not written on your paper, which means you do need to write it down, but I'll walk you through the steps. First things first is the red step where we need to set the equation equal to 0. Right now it says equal to 40x. I don't want that. But notice this is an x term. That means it's b. It should go in the center. So instead of just moving it here, I'm going to move it to the center of this equation. If it was positive on this side, it becomes negative on this side. So my equation is actually 5x squared minus 40x plus 60 equal to 0. Once it says equal to 0, I move on to the factoring step, which means I always start by checking for a GCF. If it has one, which it does, we divide by that GCF to get smaller numbers in my leftovers. In these leftovers, I now have A, B, and C. In the X puzzle, A times C goes in the top, 1 times 12. B goes in the bottom, negative 8. And 1, the A value, goes underneath the fraction. I look for numbers that multiply to 12 and will add to negative 8. Well, the things that multiply to 12 are 1 times 12, 2 times 6, and actually 3 times 3. Sorry, 3 times 4. But if I add all of those things, there's only one row that's going to give me 8. But it gave me positive 8, and I want negative 8. So instead of positive 2, positive 6, I'm going to use the opposite signs, negative 2, negative 6. I then drag those numbers down into my factors, and I'm done factoring. Now I can solve. The solve step, the green step, means I'm just taking each one of these little pieces, and I'm setting them equal to 0. But again, that first one, 5 equal to 0, that doesn't make any sense. 5 does not equal 0. Stop, just don't even do anything with that. Then the first parentheses, x minus 2 equals 0, would give me x equal to 2. X minus 6 equal to 0 would give me x equal to 6. And so we check this graphically. Let's make sure that that is true. Notice that this time when I check in Desmos, I'm not starting from the one written on paper. I need to start from the one that's set equal to 0. It's not going to look like a parabola when you put the equal 0 part. And that's okay, because we still know that that is going to find the solutions to that equation, 2 and 6. If you want it to look like a parabola, just don't put the equal 0 part, just put all of the numbers as if it was an equation. We can put y equals. But if we type in the part that is all the way solved for 0, we will verify our solutions being 2 and 6. So you should do that, again, every single time you solve one of these. You should be able to verify graphically that we got that right. Now it's time to do one together. We're going to start with the first step, which says we need to set the entire equation equal to 0. Well, I want to take the numbers towards the x squared so that the x squared stays positive. which means I'm going to take the 5 and I'm going to move it to the left, sorry. And I'm going to take the 2x and I'm also going to move it to the left. But I want to make sure this is written in the correct order, so I go in descending exponent order, called standard form, which means the x goes next. If it was 2x positive on the right-hand side, it's going to be negative 2x on the left-hand side. And if it was positive 5 on the right, it'll be negative 5 on the left. And once I have it set equal to 0, we move on to the next step. We need to factor, which means every single time we check for that GCF. There is no GCF, which is great. That just means we don't have to divide by anything, and I can go straight to my x puzzle. The numbers that I would multiply to make the top are a times c. That's 3 times negative 5, which is negative 15. Negative 2 goes in the bottom since it's b. And underneath the fraction bar is the number 3. Notice how important it is that you set it equal to 0, because otherwise your signs for a, b, and c are incorrect. So make sure you do that right. We want a list of numbers that multiply to 15. Don't worry about it being negative. I will deal with that later. Here are the only numbers that multiply to make 15, but because 15 was negative, we're going to subtract those things. We're looking for a number on our t-chart here that is equal to negative 2. Well, there they are. And since it's the correct number, negative 2, I don't need to change the signs. I would use 3 and negative 5. 3 divided by 3 becomes 1. Negative 5 divided by 3 doesn't reduce, so I'm not going to do anything with it. And I don't have a GCF to write down, so I just start with my parentheses. It would be x and a positive 1 multiplied by x and a negative 5/3. And to finish our factoring step, we would swing that denominator forward to have a fully factored quadratic here, x plus 1 times 3x minus 5 equal to 0. That's done with the blue step. I have fully factored it. So now, using the zero product property, I take each of the little pieces, x plus 1, and set it equal to 0. 3x minus 5, set it equal to 0. That's a 1 or 2 step equation for me to solve. To solve the first one, I would do the opposite of positive 1, which is negative 1. So x is equal to negative 1. For the second one, it takes 2 steps to do this one since there's a number in front of x and behind x. So we'd have plus 5 on both sides. And then to get that x fully by itself, we would divide by 3 on both sides so that it cancel out. This would be x equal to 5/3. Again, you can verify digitally or on your calculator that these are the same. Notice that since this is a fraction, you should get a decimal whenever you check on Desmos, and it should be about 1.67 if you're checking. But I would prefer the fraction answers. Here's something I want you to notice, which might be kind of fun. Do you recognize something about 5/3 anywhere else on this paper? I noticed that the number 5/3 is very similar to the number I got out of my x puzzle, negative 5/3, before I swung that denominator forward. I also noticed that negative 1 looks familiar because it's the opposite of positive 1, which I got out of my x puzzle. That's going to happen every time, which means doing the swing and divide factoring, you could actually stop here if it doesn't ask you for factored form and set those equations equal to 0 and solve. Just cuts out 1 or 2 steps from the problems. But if you didn't notice that, that's okay. Follow the steps listed on your paper. Fully factor it and then solve those equations, setting them equal to 0. Now we have only one more example we're going to do together before you're going to be asked to finish the 2 examples on your own to be checked off for your notes today. In number 3, we would need to set it equal to 0. That's the first step in solving a quadratic, but it's already equal to 0. We're happy we don't have to do that step. So we go to the next step. Now, you could set up an X puzzle and solve this, but if you notice that this is the difference of 2 squares, we have a pattern we learned about in the last lesson about if you are subtracting 2 things that are both perfect squares, it's going to automatically factor using this pattern. Now, I see I only have 2 things. That's pretty close to this. I need to make sure that they're both perfect squares. Now again, if you don't see this, you can use an X puzzle for this and it would totally work. But I notice, because there's two things that I'm subtracting, that this is actually 3x squared minus 2 squared equal to 0. Those are both perfect squares because 3 squared is 9 and 2 squared is 4, which means I can very quickly factor this to 3x minus 2 and 3x plus 2. And once it's factored, again, either with an X puzzle or using that pattern, I can take both of these little pieces, set them equal to 0 using the zero product property, and then solve. Add 2 to both sides. It'll get rid of this. We have 3x equal to 0 plus 2, which is 2. Divide by 3 to get x all the way isolated. X is equal to 2/3. I think is going to be one of my solutions. Then do the other one. Opposite of plus 2 is minus 2. Opposite of times 3 is divide by 3. And I get x equal to negative 2/3 as my other solution. But always verify your answers. There's no reason to do one of these problems and not verify your work at the end, because you're so easy. Just type it into Desmos or your calculator and verify that that's where the graph crosses the x-axis. So we've done 4 examples of this type of work, and you have 2 more that I want you to do before you are done with your notes. As a hint, in this problem, you will be using an X puzzle. And in this problem, you can eventually, after checking for a GCF, use the difference of 2 squares pattern. But if you don't see it, go ahead and use an X puzzle. But I want you to go ahead and factor and then solve number 4 and 5 before you're done with your notes for today.